Lani. She will tell us something more about ASR 9000 network virtualization. Kashish, over to you. I'll just unmute you. Okay, you're unmuted.
Thanks. Yeah. Hello, everyone, and welcome to this session on the ASR 9000 network virtualization. My name is Kashish Golani, and I'm a technical systems engineer at the Customer Proof of Concept Labs in UK. This is the agenda for the hour. I'm going to start with the ASR 9000 NVH system overview. Going to give you a very brief overview on what this solution is all about, and I'm going to discuss the target market segments that you can keep in mind when you try to deploy the solution with your customers. Also going to cover the hardware and software requirements that need to be considered when talking about the solution to your customers. Moving on, I will move on to the NV satellite market and evolution. It's going to be the satellite value proposition, since the NV satellite is a new product wherein the different topologies that are currently supported in the code, and also the different hardware and software requirements that you have when deploying the NV satellite solution to your customers. Also, there are a lot of new terminologies that you need to keep in mind when you talk about the solution. So I'm going to have a few slides that covers the new terminology that is being introduced by the satellite solution. And also, there are certain features that are not currently supported. So I'm going to talk about all of those features and also the new features that are in the roadmap in the next year for the satellite solution. Before we get started, I just wanted to give you a very quick overview about CPOC. Our vision is to inspire customer confidence through world-class demonstration and validation services. As you can see, we are located in Building 11, ground floor. We have a very impressive lab of 315 square meters. Our customer-facing labs offer on-site and virtual testing services to your customers, aligning to the latest technologies and architecture play. We have telepresence facility in CPOC, so we can also, we can do virtual as well as on-site customer CPOCs. We have a very impressive team of 7 engineers. We are strategically located around the globe to help with high revenue, strategic, and highly competitive pre-sales opportunities. So moving on about the ASR 9000 NVH solution. So service providers worldwide face high customer expectations along with growing demand for network services. So there is a constant need for efficiency, high availability, and also rapid time to deployment. In order to support all of these required density and high availability requirements, the service providers need to use various different routing platforms and also sometimes complicated routing protocols. So all of this increases the operating costs of the service provider and also the time to deploy. So now Cisco is offering this revolutionary approach to high availability and access virtual network and also the access network density. So it's based on this virtual network architecture. As you can see from this slide, we're leveraging the existing iOS XR CRS multi-chassis software infrastructure. Cisco has simplified or even enhanced that solution, and it has introduced the network virtualization, that is the NV technology, in the Cisco ASR 9000 series router. So what happens if you deploy this? So by deploying this technology, the service provider can simplify the network, they can reduce the operating costs, and also improve the network and service resiliency. And all this can be done while even supporting greater scale and density. So in this next 1 hour, I will provide you with an overview of the Cisco virtual network architecture model and describe how this capability can be used to optimize your edge and access services. So the first target market that I'm going to talk about is the wireline aggregation. Now, in this market segment, in order to achieve high availability in today's network, without your NV cluster solution, your service providers have to use a dual homed architecture and a protocol-based resiliency approach. Now, this approach is inherently very, very inefficient. Now, that is because at a minimum, in order to deploy this model, you at least have 3 separate set of protocols that you need to control. You have to dual home the access layer device to each node. So there is either MSD or rep aggregation that you need to run in the layer 2 ring. To communicate, the communication between you have to communicate between the nodes to achieve both layer 2 and the layer 3 service resiliency. Also, the synchronization of the state between the two nodes have to be done. So there has to be complex inter-chassis state sync protocols that need to run in order to synchronize the state between the two chassis. Adding to this already complicated approach, the network operators also often must use different protocols for each of the different layer 2 or layer 3 services in the environment. Each protocol may be more or less complex to provision depending on the services and the network topology. If you have an Ethernet hub and spoke kind of a model, you have to run MC-lag. If you have a layer 3 router, you have to dual home that, and there will be 2 ECMP paths from the layer 3 router to your aggregation. So in addition to all of these protocols that need to run, this protocol-based approach also employs, there is more layer 3 routing adjacency, which means that the layer 3 topology changes during a node or a link failure, and hence that slows your convergence time. So if you kind of think about this, instead of this dual homing approach, if deploy your NV Edge solution, it provides an alternative approach that addresses all of these concerns. It also reduces the complexity in the network and improves the convergence time. Also, by using the solution, the network operators can link 2 physical chassis as a single virtual chassis, replacing dual homing by single homing and using a single control plane. So as you can see, you replace the dual homing by the single homing by kind of linking both the chassis as one virtual chassis, and you also have a single management plane and a fully distributed data plane. So all your services are synced between the 2 chassis naturally. And not only that, your convergence is going to be independent of the scale of the services that you deploy. Your access you can simplify your access dual homing by having a regular active link bundle. So all of these things the NV Edge solution is going to simplify your deployment and also make it very easy for your network operator to manage the network. Now, the next target market case study that I'm going to talk about is mobile aggregation. Now, in the typical mobile aggregation market, you have a cell site router, which will be a layer 3 router, and it's going to have a dual IGP or BGP adjacency between the cell site router and the 2 aggregation routers. So if there is a failure in the link or the node, your layer 3, your routing protocol has to reconverge, and that is going to increase your convergence time. Again, between the aggregation routers, you will have to sync the state, so you will run either HSRP or VRRP between the 2 aggregation devices. So the convergence time is going to be either sub-second to second, depending on the scale of your network. Now, in this kind of a mobile aggregation market segment, if you replace your 2 aggregation devices by one single cluster, you will have one virtual control plane to manage. You do not require to run any HSRP or VRRP between the 2 aggregation devices. Also, your cell site router will have just one single BGP routing adjacency or IGP adjacency between the cell site router and your NV Edge. So again, there is not going to be any layer 3 routing change when the link or node failure happens. So your convergence is going to be very quick, 50 millisecond to sub-second convergence, and that is going to be independent of the scale in your network. So again, a simplified solution, less layer 2 and less layer 3 routing protocols to run, and easier for the operators to manage. Our third target market is your data center interconnect PE. Now, in your traditional way, you will have an active standby MC lag between your in your data center, and again, there would be the sub-second to couple of second convergence time, depending on the scale. Also, between the two data centers, you will have to run between the two PEs in each data center site. You will have to have a full mesh of pseudo wires. So that would mean more control plane overhead. If you replace that by the NVH solution, effectively you will get an active link bundle per flow load balancing. So you will have very quick convergence time of 50 milliseconds. And since you can just have one pseudo wire, you will in the NVH system in each data center site, you reduce the pseudo wire scale by 3/4. So you simplify the operation and also get better convergence time with the NVH solution in your data center PE as a data center interconnect PE. In the L2 VPN dual homing scenario, one of the best solution in the market currently is the MC lag with the two-way pseudo wire redundancy. In this solution, you deploy an active standby MC lag. So that is very bandwidth and inefficient. Also in the core, you will have to deploy 4 pseudo wires with 1 active and 3 standby. So this is again has a lot of control plane overhead. Also, your pseudo wire failover time will depend on the number of pseudo wires, so you will have very slow convergence. In contrast, if you deploy your NVH solution in this scenario, between your access and your aggregation, you could have an active regular lag bundle. So that effectively is very bandwidth efficient. In the core, you could have a single pseudo wire. So both your link as well as your node is protected by the lag. And in the event that a link or node fails, your pseudo wire is not even aware and it doesn't go down, and hence you achieve super fast convergence. Your state is synced naturally between the two chassis, and so this pretty much simplifies your network, and also you get very super fast convergence independent on the which is independent of your pseudo wire scale. So the requirements, what are your cluster requirements? In order to deploy the cluster, in order to physically link two chassis together, there are a few of the requirements that you need to keep in mind. In order for the control plane to sync between the two chassis, you have to use your special NB ports which are available on the RSP440. Currently, the connections or the EOBC links have to be layer 1 transport only, and you have to use Cisco optics only for those connections. So these are the 10 gig connection between the two chassis, and they are used to sync the control plane between the two chassis in order to form the cluster. In order to sync the data plane, there you have to have the links that are used to connect are called the inter-rack links. There is a requirement to have a minimum of 2 inter-rack links and a maximum of 16. These links have to be 10 gig Cisco. They have to be 10 gig links, and they have to have Cisco optics. And currently, the only supported is the only L1 transport layer. There has to be only layer 1 transport connections for the data interact links. This slide also shows you that you now, in order for redundancy, it is recommended to, if you're using only 2 interact links, it is recommended to have them on separate line cards. Also, there you could have regular data links and the interact links on the same line card. There is no specific limitation that you can't have data links on the same line card that you have configured your interact links. These links are implicitly bundled, so you don't need to bundle them. That is all done implicitly. You just need to specify the links that you are going to use as your interact links between the two chassis. The requirements for deploying the cluster are you definitely need to use the new RSP 440 because this is the RSP on which you have the special NB ports which are used for the EOBC connections between the two for it to sync the control plane. You need to use only Typhoon line cards. Trident line cards or the RSP 3G cannot even coexist in the same system. So even if you are not using it, but you have it powered on in the same chassis, you will not be able to form the cluster. So you don't need to have any Trident line cards or any of the old RSPs even present in the same system that you are trying to form a cluster. You require a cluster software license on each chassis. The license is around $15,000, and that license has to be applied on each chassis. So if you are clustering two chassis together, you need to have two licenses on each you need to have a total of two licenses, one license per chassis. A minimum soft image of 4:1 or above is required in order to form the cluster. Also, only like-to-like chassis is supported in 4:1. You cannot have mixed chassis support in 4:1, but that is planned for future release, but it's not yet committed. Single RSP per chassis. So currently, in order to form a cluster, you need to have two RSPs per chassis. Single RSP per chassis is supported, but it is not recommended due to lack of fabric redundancy on the physical chassis. I have myself tried it, and it is possible to form the cluster with just a single RSP, but it is not a recommended configuration for a cluster, and it is not supported. It is supported. So there are certain limitations which you need to keep in mind when you are deploying the cluster. Your inter-chassis data link does not support 40 gigs or 100 gigs. The inter-chassis data link has to be 10 gigs only. Your EOBC links, which are the special NV ports on the RSP 440 that are used to sync your control plane, they are not user configurable or visible. That's only plug and play. You just need to connect them, and there is a specific order in which they need to be connected in order to form the cluster. So you have to connect them in a specific order, and they are not user configurable. There is also, since they are not user configurable, you cannot configure any COS on it. So it has implicit Fabric QoS by default on the inter-chassis data link. There are some of the features that are unsupported in 4.2.1 and also moving on in 4.2.3, which is multi-hop BFT, Syncy, and 1588. They are not supported. There is also one of the most important things is there is a software upgrade caveat wherein in order to convert two physical chassis to a cluster, you need to reload the chassis, and that effectively means that you have a downtime of around 10 to 15 minutes. So that is a very important caveat which you need to mention to your customers if you are considering deploying the cluster. One of the chassis has to reload, and that effectively has a downtime of around 10 to 15 minutes.
Kashish, before we go into the configurations, there is a question asking about the third scenario that you were considering. Asking what are the advantages of using ASR 9K NV versus using 6500 VSS for the data center interconnection?
Yeah, let me go back to the slide. Well, in terms of there is, I guess the only difference is when the ASR 9K has got the iOS XR, so you will have it just a better iOS to run on it. But there is in terms of there is nothing specific that 9K you will have more just a better iOS XR that runs on it, but otherwise it would be pretty similar because I think you will again have an active link bundle, so you will get load balancing in the same way. But in terms of specifically to the 6500, I think it just have the iOS XR that will be different than the 6500 that you will run if you're running VSS.
Okay, thank you.
So for the NVH configuration, you need to keep in mind that you need your serial number that you need to have before you go ahead and configure the cluster. You need to specify the serial number and the rack that you need to have two racks, rack 0 and rack 1, that you will be using to form the cluster, and you need to specify the serial number for that particular rack in your NVH configuration. So that is the global NVH, that is the configuration that you need to configure the NVH globally. Then for configuring the inter-chassis fabric link, you need to specify which links you are going to use for the fabric links, and the configuration for that is you just need to specify on that link that it is used for as an NVH interface, and that would effectively configure that as a fabric link. There is no other configuration that you can do on the fabric link. You can't configure any QoS or any other configurations. The only configuration is to just specify that link as an NVH interface. I have some sample show command outputs just to give an understanding of how it looks like once you can physically link the two chassis into a cluster. So the first, if you can see in the node, it starts with the rack number. So we have, as I said, you have to have one chassis as rack 0 and one chassis as rack 1. So in this output, the role and the state is important. So the primary DSC is the primary rack in your cluster. So as you can see from this output, rack 1 RSP0 is the primary rack in the cluster, and rack 0 RSP1 is your backup RSP in the cluster, or the backup rack in the cluster. So if the primary rack goes down, or the RSP1 in rack 0 will take over and will become the active rack. So it is going to protect your primary rack. And in your primary rack, you have RSP0 as your active RSP. So if that RSP fails, then the standby RSP in that same rack takes over and becomes the active. So that is one thing that you need to keep in mind, because there are 4 different RSPs. So the idea of failover still exists. If the primary RP in the rack fails, the standby RP in that rack takes over. But if the entire rack fails, then the backup DSC rack will take over, and the RSP in that rack becomes the active RSP in the chassis. There is once you form the cluster, if you execute the show platform command, you will see the type of RSPs that you have, and also it will give you more detailed information about which is the active and standby RSP in the cluster. So moving on, the next few slides are going to target the NV satellite solution. I'm going to talk in more detail about the NV satellite value proposition, and also the different topologies that we currently support for the NV satellite. So in today's deployment, without the satellite, in your typical deployment, if you have on your NNI side, it is usually manual configuration without, and it's not plug and play. You will have to, if it's a layer 3 NNI, you have to run IGP, LDP, BFD, and all of these protocols. If it is a layer 2 NNI, you will have MCLAG or STP or some of the layer 2 protocols running. So it's again multiple protocols. It's complex. You have to have potentially complex dual homing, and also there has to be manually configured. It's very difficult to get a network management solution which will help you in that configuration. From a UNI side configurations, you could rely on good network management for provisioning, but usually if it is a layer 2 UNI, you have to have your complex VLAN provisioning. It has to be provisioned on all of those layer 2 devices. Again, you might have some Q&Q for certain customers, and again, which would require double tagging. For layer 3 UNI, and if you have a layer 3 device, you will have additional layer 3 routing, or you would have configured. You will configure different VRFs for your different customers. You have to run BFD, etc. So all of this becomes complex to configure and manage. Again, you have to have you might have different iOSs running in your access and in your aggregation, so you will have interoperability issue, or you might have some feature inconsistency between your access and access or aggregation and your edge system. Mostly you might, since the iOS is different, you will have different CLI or management experience between the two. So that just effectively means that your management and configuration is more complex and difficult, and also it's different. They might see different bugs in different access devices and the aggregation, so it's difficult to manage and difficult to configure in today's deployment. So if moving on, if you replace that with your satellite solution, what are your operation savings? So currently the way the satellite works is it is just plug and play. You just need to connect your satellite to your host, and it gets automatically discovered by the host. There is a Cisco proprietary protocol, which is the SDAC, the Cisco Discovery and Control Protocol, that runs between the satellite and the host, and that is used for automatic satellite discovery. So you kind of avoid the complex protocols that need to run for your dual homing. If you want to dual home your access to your aggregations, there are all the complex protocols that you need to configure. Those are all avoided, and this is all done automatically by the Cisco Discovery Protocol that runs between the satellite and the host. Also, the provisioning of the UNI is centralized. All of your UNI is provisioned from your host side, so it's all centralized provisioning. You don't need to run any layer 3 routing or layer 2 protocols on the satellite. Everything is done on the host. You have just one virtual device to manage and operate. Again, all your satellites are managed from your host. So even if you want to upgrade your satellite, that is done from the host, and you have a single iOS XR user experience. So there is no problem of the feature inconsistency or no interoperability issues between your access and your edge system. Again, it is very simple to operate. It is much more stable than your standalone deployment, and there is less chances of running into a software bug or needing any software upgrade. Currently, once you buy your satellite, it has a golden image that is loaded on it, and as soon as you connect it to your host will push the software image onto your satellite, and that is done automatically. And whenever you upgrade the host image, you have the option to upgrade the satellite as and when you want. So you can schedule a period of downtime when you want to upgrade the satellites. It is a two-step process where first you could transfer the new image onto the satellite, and that takes some time, and during that time the satellite is still operational and it's working, and then you could go ahead and activate the new image, and that takes around 2 to 3 minutes. So you have an effective, you have a downtime of around 2 to 3 minutes when the new image gets updated on the satellite. Again, there is currently no distance limitation between the satellite and the host. They could be they could be really long distance apart. There is just limitation of the latency, which needs to be less than 10 milliseconds. But other than that, they could be any distance apart. And in order to deploy the solution, you need to have special licenses. So currently, the satellite license you need to is around $25,000, and that is for 5 hosts. And there is a satellite license of around $100,000, and that is for 20 hosts. So you need to have those licenses in order to deploy the solution. The supported satellite topologies. So the way you connect your satellite to the host, there are some restrictions. There are some supported topologies and some topologies that are not supported and some that are in the pipeline. So currently, you could either single home, just connect the satellite to one device and do static pinning. So you specify which. Before we go ahead, I just want to go back one slide. So these are your satellite access ports. The one in red, they are your satellite access ports. They are the ones that you connect to your access. The satellite has around 44 1 gig ports, and these are your access ports. And your NV fabric link is your link between the satellite and the host, and they are the 10 gig ports, the 10 gig links that you connect between the satellite and the host. So this is the connection. This slide will talk more about the connection between the satellite and the host, the NV fabric links that I spoke about in the previous slide. So you could either single home your satellite to a single ASR 9K host and use static pinning, or you could connect your satellite to a single host and use a fabric link bundle. So you could have 2 or 3 or 4 interfaces connecting the satellite and the host, and you could bundle them all together. The other option is to connect your satellite to a cluster. So you dual home it to a cluster. Currently, the supported configuration is dual homing to a cluster. You cannot dual home to 2 separate aggregation or 2 separate devices. It has to be a cluster. And you could do static pinning, wherein you specify which access port is going to use which fabric link. And the last option is to dual home to a cluster with a link bundle. So you can bundle up the interfaces, and then the access ports are going to randomly use those interfaces in the bundle, so you don't do static pinning. The satellite must have direct Ethernet over fiber or copper, or Ethernet over optical. So you could have Ethernet over SONET, SDH, or DWDM network. So it could be any of this, but it could be any distance apart. It has to just have a minimum latency of 10 milliseconds. There are some unsupported link bundle configurations. The most important is that if you bundle your fabric links, that is the link connecting the satellite to the host, you cannot bundle your access ports. So that is a very important limitation which you need to keep in mind. You can't have a bundle on both sides. You can just have bundle on either one of those sides. So that is one, and the other is that you cannot bundle member ports across the satellite access port and the local port. So that is also not supported currently. There are certain topologies that are considered for future release. One of the most important things that many customers want to see is hub and spoke, where you are going to 2 different devices, not really a cluster. So that over a layer 1 or layer 2 fabric, so that is targeted for future releases. The other thing is a single ring, but over layer 1 or layer 2 fabric and going to two separate aggregation devices, not to a cluster. Then there is a 2-level hub and spoke kind of a setup. This is not yet EC'd, and that is also something that is hopefully in the pipeline to be developed. There is a spoken hub, a cascading spoken hub kind of a setup, which is again in the pipeline. A cascading ring and a 2-level cascading ring are some of a few of the topologies that are in the pipeline to be developed, and some of them are CC'd, some of them are not yet EC'd. So it is all in the pipeline for the next few releases coming out. So the requirements, both the hardware and the software requirements for the satellite solution. So 4.2.1 was the software version that introduced the satellite support on the ASR 9000V. They were at that time only the 9006 and 9010 were the supported host chassis. The most important thing is that you need to have the satellite PI that must be installed on the host. So that is the PI that you need on the host, and that is the one that has all the software that gets pushed onto the satellite. Only the Typhoon line cards, which are both flavors SC and TR, support the satellite fabric ports. You cannot use your Trident line cards as your fabric ports. However, you can have both RSPs are supported, so you could deploy the the satellite solution on a chassis with new line cards but old RSPs. And again, both the SC and TR flavors of the RSPs are supported. Your satellite access port, they support both. They support all 10, 100, and 1000 with auto negotiation with both duplex and half duplex. Again, also both fiber and copper optics are supported on the 1 GB access port. Also, there is a 4.3.0 release, which is targeted for December this year, which will possibly introduce the 901s and the 903 as satellites, and also the 9001 and 9922 as the host. So this is a possibility of few more satellites being introduced and few more hosts in the 4.3.0 software version. So satellite terminology is very important. There are a few things that are different here, and since it's a new product, this is something that you need to keep in mind. So this is the ASR 9000B is the satellite, and this is connected to the host by the fabric. So the connection between the satellite and the host is called the satellite fabric link. The port on the satellite that connects to the host is called the satellite fabric port. And the port on the host that connects to the satellite is also called the satellite fabric port on the host. It has to be any 10 GB port on a Typhoon line card. On the satellite, there's the 1 GB ports. They are called the satellite access port. And for every satellite access port, there is one NV Ethernet port that shows up on the host when you do a show interface brief. So if you have now how is this NV port represented on the host is very important. So as I said, you have 44 GG ports on your satellite, the 9000V. There is every satellite, when you configure the satellite, you need to give it a specific ID. In my case, I have a satellite ID of 101. So for that particular satellite and all of its 44 GG ports on the host, I will have 44 NV Ethernet ports that get created, and they will be named as GG 101/000, going from 000 to 0043. So 101 is the satellite ID, and 0 to 43 are the 44 ports on which are the access ports for that particular satellite. As I said in the previous slide, these fabric links could either be bundled or they could be statically pinned, and you need to define which access port is going to use which fabric link. Either you could statically define which port is going to use which fabric link, or you could just bundle all the fabric links together, and then it's going to be just using any one of the interfaces in the bundle. So that's an important thing to keep in mind. This is the satellite terminology, and it's important to know that there are these NV ports that get created on the host. Here I have a satellite configuration example. So as I said, you have to when you need to have every satellite is identified by its satellite ID. So once you configure it, while you're configuring it, you need to specify the satellite ID. You need to specify an IPv4 address. So this is an IPv4 address that is just used as a management address between the satellite and the host. So from your host, if you telnet to this address, it will take you to that particular satellite chassis. So it is just an in-band telnet is an in-band management that is used between the satellite and the host. It is advisable to configure this in a VRF, a separate VRF, and also in the next releases going forward, it's I think 430, 431. This is going to be configured automatically, so you don't need to specify a particular IP address or a random IP address that it's going to use for management between the satellite and the host. So in this example, I have connected two satellites to my particular host, and I have given them different satellite IDs. So once you define the satellite, the other thing that is important to do is to define the satellite fabric ports and the access ports. So in this example, I have created a bundle interface, and in that bundled interface, I have specified the fabric that it is a fabric link, and I have specified the remote ports that it is going to use. So in my particular case, it is I have created a bundle Ethernet, and that is going to be a fabric link for satellite 1000, and a bundle Ethernet 2, which is going to be a fabric link for satellite 2000. And the most important thing you have to see here is the remote ports. This is the configuration that is going to specify the remote ports that are going to be used by that fabric link. So in this case, since it's a bundle, all the 44 gigi ports on the satellite are going to use that bundle. But if you use static pinning, then for every 10 gig interface or 10 gig interface that you configure as a fabric link, you need to specify exactly how many access ports are going to be used by that 10 gig fabric link port. So that is what you define in this configuration. So there are at FCS there were some features that are unsupported on the satellite. One of them is the BFD. BFD is not supported on the satellite access port. So features like MPLS-TP that depend on BFD will not be supported. The other thing is that satellite access port link bundle is only supported with static pinning. So you cannot have the access port link bundle and also bundle in the NV fabric link. That limitation is also not removed in the future releases. That limitation is going to be there. There is no ISSU support for the satellite. So when you upgrade the image on the satellite, you will have a downtime. Currently, the ASR 9000V has a downtime of around 2 to 3 minutes. That's the time it takes for it to activate a new software on the satellite. MAC accounting and fast reroute is not supported on the satellite access port, and also WIDMON is not supported on the satellite access port. Again, Vidmon is not supported for traffic that is entering or that comes in on the access port. However, on the ASR 9K host, if you have traffic coming in on any other normal data port and going out on the satellite access port, then Vidmon will be supported. Because since Vidmon is a ingress feature, if the ingress interface is on any other any other data port of the host, then Vidmon will be supported, even though it egresses out to the satellite access port. Only if the traffic is coming in on the satellite access port, then Vidmon will not be supported. Also, the other thing to keep in mind is QoS. Most of the features, most of the layer 1 features get applied on the satellite, but other than that, all of the other features are applied on the host. So there is, if you apply any marking or policing or anything on the satellite access port, then all of those QoS features are actually applied once the traffic reaches the host. So between the satellite and the host, there is no on the fabric link. There is nothing explicit that you can configure. There is some implicit cause in place that is currently used to control the QoS on the fabric link. But there is if you configure any explicit cause, then that will not be applied until the traffic reaches the host. So that is another thing to keep in mind. Also, multicast replication happens on the host. There is nothing happening on the satellite. The satellite is just like from a satellite perspective, it's just like a layer 2x connect. It just gets the packet on the access port and sends it out on the fabric link towards the host. The features that are introduced in 4.3.0, this is pretty much in coming out in the next few weeks, is BNG support. There is the BNG is going to be supported on the satellite, and the only supported for non-bundled ICL and bundled access port. So that's another thing that you need to keep in mind. It's not going to work if you bundle the ICL, then that will not work. So you have to keep that restriction in mind when you propose the BNG support on the satellite to your customers. There is AAA support on the satellite. So pretty much currently, as I said, you from your host, when you configure the IP address that I specified here, 6662. So on the host, when you configure the satellite, the IP address that you use to configure it, if you telnet to that, it will take you to your satellite chassis. So currently there is no restriction. Anybody can connect to your chassis connect to your satellite from your host. You can telnet to it. So there is this feature that they are introducing in 4.3.0, wherein you have some AAA supports. You could set some passwords and restrictions to that access, and you can restrict your telnet access to your satellite. So it gives it some security. And the other thing that is coming is your mix of ICL lag and no lag for all ICL links. So what does that mean? That effectively means that currently there is no support of. So currently, if you bundle your fabric links, you either have to bundle all of them or you have to use static pinning. There is no option to bundle a few and not bundle a few and leave few as static pinning. But going forward in 4.3.0, that feature will be introduced where there will be that option of bundling of few and leaving the few as static pinning. So you could you could have static pinning for a few of them, and if that as a failover option, if that fails, then if that link goes down, then you could use the bundle as a backup. So that is another thing that is coming forward with the 4.3.0 release. So pretty much that's what I had from the satellite perspective. The other thing to keep in mind is that we have very good and resiliency with the entire NV Edge solution. So if you are using a bundle between in the Fabric link, and if one of the interfaces in the bundle goes down, you will see that you have less than 50 milliseconds failover, like hardly few milliseconds of failover time. Also in your satellite access port, if you use a bundle and if there is a link down, you have very good resiliency numbers. Even I have tested it in the CPOC lab, and in your cluster, if one of the chassis go down, the failover times is very good, less than 50 milliseconds. Also, if there is there is protection in place if you lose your data links or if you use your control plane links. So it's a very good solution. It has been tested very well. I have got a very good demo in CPOC, wherein I have I have deployed a lot of layer 2 VPNs and layer 3 VPN services on the satellite, and I've tested them, and it really works. So I hope you can talk about this technology to your customers and see if there is a possibility of introducing this into their network. So that is all I had from my side. I thank you all for listening. And,
thanks a lot, Kashish. We have a couple of questions, if you could review them now. First of them is from Joan Brunet, basically asking that in a situation in which you have two ASR 9K in a standalone configuration and you want to migrate them into a clustering solution with ASR 9K, how can you migrate the configuration? You should pre-configure the interfaces?
The two ASR 9Ks are so you have two separate ASR 9Ks and you want to move them to a cluster, right? And you want to even migrate the configuration?
Yeah.
Yeah, so first of all, I guess the most important thing is the software has to be to 4.2.1 on both of them. And the other thing is there is so you need your standby or the backup rack that you have, rack 1, you need to power that down. So you need to pretty much, it's going to, you will just power it down, and then you will configure your NV Edge on your active rack, and then once you power on the backup rack, it is just going to pull all the configs from it will just pull all the software and the configs from the active rack. So there is nothing specific you need to do. You just need to schedule a downtime and a downtime for it and follow the instructions on how do you configure a cluster out of two separate chassis. And once you do that, the backup rack is just going to pull all the configs and the software from the active rack. So all your configurations will be synced between the two chassis.
Okay, perfect. So another question from Harinda Fernando. Asking in which release the ASR 9K ring architecture will be supported with clustering?
Yeah, so that is, I think, I think most of my customers also want to know when the ring thing will come out. So it is targeted for 4.3.1 release, I think, and I'm not sure if that is still the case or if it's going to slip, but that is what was the last thing I knew that is going to come in 4.3.1.
And the date for 4.3.1, do we have an estimation?
I think in April of next year.
Okay.
So 4.3.0 is December, and then April of next year is when 4.3.1 will come.
Mm-hmm. Okay, and the last question that we have, what are the parameters to consider for the number of links for Fabric data path between two chassis?
Well, it's recommended to have 2 and a maximum of 16. So I guess what you need to consider is if you're doing static pinning or if you're bundling them all together, the amount of bandwidth that you need. So it's pretty much going to be it's always recommended to use at least 4 between the two, and your gigi, the bandwidth you want to provision in your access is what is important. The customers that you want to provision in your access port is important because it is going to use that particular fabric link to send the traffic from the satellite to the host. So it all depends on your provisioning of your bandwidth on your access side that you're going to use. Is what you're going to use to determine your fabric links.
Mm-hmm. Okay, 2 more questions just arrived. First of them is, when ASR 9K is in clustering mode, will it give a similar field to the one that we have in the CLI for VSS?
Will it be a similar?
A similar field in the CLI. It will look from the CLI point of view similar to VSS.
Yeah, from a CLI point of view, it is just going to be exactly like how you have a normal ASR 9K. Nothing is going to change. The only thing will be that you will have more interfaces. So you will have the first thing, you will have the racks. All of the interfaces from both the chassis is going to show up on when you connect to the active chassis. And pretty much you are going to have your rack number is very important here, because the first like if you have 10 gig 0001 or 1001, so the first number in that is your rack number, and that is very important for you to know whether that interface that you are configuring is in rack 0 or rack 1. So once you tell it to it, it's going to be very similar to as if it's just a single RSP. Nothing is going to change. You will just have more interfaces in there. Other than that, everything is going to be the same.
Mm-hmm. Okay, thank you. And the last question is support for IP over DWDM in the fabric links.
That is IP over DWDM is currently supported in the fabric links, right?
Okay, so it's already supported.
Yeah.
Okay. Perfect.
Okay, I can see that we don't have any other questions, so I would like to thank to Kashish and for Julio for being with us, and I would like to thank the audience for joining us and for asking the questions. I would like to ask you to let us know your feedback straight after the session. There will be survey available. Please take 1 or 2 minutes and fill it in and let us know how did you like the session and what you would like us to improve. Also, if you have any recommendations or suggestions, please use the email address you can see on the screen, and also it's in the chat window. As I said, this event was recorded and you will receive the link to recordings and presentation in a couple of days. There are some more events coming in the next days, so please register and join us. If you would like to receive our invitations on a regular basis, please sign up by sending me an email. Just before we finish, I can see that there is actually one more question, so if we can take the last minute, that would be great.
Okay, last minute question. Kashish, do we have tunable SFP Plus?
No, that's not currently supported.
Okay, so it's plain IP DWDM, but we fix
plain
web
IP
lanes.
over WDM,
Okay, cool. Thank you.
Great. Thanks a lot.
Yeah,
and have a nice rest of the day.
Yeah, thank you, everyone.